Your screen, Dennis. But anytime I make to fill my screen, it cannot move. And is your slide moving? Okay, that's great now. So today we are going to look at introduction to industrial programmable controllers. And by the end of the lesson, the learner should be able to. Those are the objectives down there. So for the definition part, we are dividing the word program as a set of instruction or command that computer uses to perform specific function. Therefore, the word programmable is the ability to receive and contain program. Program can also be defined as a series of coded software instructions to control the operation of computer or other machines. The word logic is a feature of being in two states, 0 and 1, on and off, or true and false. Controller is an hardware device that manages, regulates, directs the flow of the data between two entities, that is the input and the output. Therefore, programmable logic controller is a computer, hardware, and a program that uses set of instructions to regulate a machine. Then let's look at the common components of basic PLCs. There are five basic components of programmable logic controllers. These are the input. Example are the switches, push buttons. You can name the rest. The other one is CPU. CPU stands for Central Processing Unit. This is the module process and transform the data from the input to the output. The other module is power supply. CPU needs power to manipulate signals. The other one is HMI. HMI stands for Human Machine Interface. Remember, when we were defining a program, we say is the ability of a machine to receive and contain data. So HMI help the machine to receive software or the instruction from the user. And then the last module is the output. So there is the diagram that shows you the architecture of the common PLCs. And make sure you can see that I've said common PLC. This is the common one. There are other PLCs that are very complex. So the complex programmable logic controllers contain more than one modules. You can see here that we have only 5 modules. But the common one in the market, the complex one that are in the market, the processor can be even divided into 6 parts. The HMI, different kinds of memories, depending on the complexity of the process of the plant to be controlled. So that is the basic one. You can see different. You may find different one in the market, but this is the basic one. You can see we have power supply up there, and then there is another module down there, the purple one for programming devices. That one represent ports and HMI. That is where you can put your program or instruction to the CPU. There is the input module there on your left hand side. That is, it represent all the ways or all the ports that can allow you to input your signals. And then there is the output module there. So that is a diagram. Then we go to the need for PLC. Why do we need PLC in our industrial setup? So number one is the accuracy and reliability. Programmable logic controllers are accurate to fault. Unlike standard programmable equipment. The likelihood of PLCs failing is significantly less. When correctly installed, PLC allows you to accurately monitor things such as your alarm, HVAC, and navigation system. This prevents system malfunction and makes for a smooth chatter. The other one is performance. Industries need better performance. So PLCs can perform a variety of tasks that are even more complex than those of personal computer system. The third one is PLCs needed to minimize maintenance cost. The advancement of science and technology has allowed manufacturers and marine electric engineers to develop less complex programmable logic systems. Most modern PLC controllers don't have hard drives or other moving parts that would require constant maintenance. So PLCs help you to minimize your maintenance cost. Simplified process monitoring. The PLC engineering system can allows for an advanced content communication that will give you pertinent information such as electrical malfunction, temperature, and processes and data interface. The fifth one is safety precaution. That is self-explanatory. You can explain for yourself. The most PLC uses pneumatic signal. A pneumatic signal is different from electrical, which are usually dangerous. It requires a lot of precaution. But for pneumatics, they are safer. They are intrinsically safe. Uh, PLC you can operate it at the comfort of the control room, unlike the relay system and the manual control. So, what are the types of PLC you know in the market? We classify programmable logic controllers according to the architecture, but it can also be classified according to other things like the size, like the brand name like we have CMN, Annual, etc. But for our case, we classify PLCs as according to the architecture. And there are three types, as you can see in the diagram. There's fixed PLC, where all the modules are combined intrinsically into one, like you can see in that diagram. The second one is modular, where all modules of PLCs like the input, power supply, CPU are distinctively separated as shown in that diagram there. You can be able to separate, but they are in one place. And the third type is distributed programmable logic. Are we together? Can you hear me? Are we together, class? Okay. So the third one is the one you can see in that diagram. It is called distributed programmable logic controller. It is in a setup where there is complex processes to be controlled. Where one module, for example, the input module, you can find it in one room. The CPU module, you can find it in the next room, for example. And the output module, you can find it in another room. So it is called distributed because modules are distributed in various places. So that's all about programmable logic control. In our next lesson, we are going to look at SCADA system. Remember, our unit was industrial software control. So we have covered programmable logic controls. The next one is SCAD. Thanks for now. If you got a question, you can get me through our link or through our comments below. Subscribe for my channel down there. Thank you.